So I hope you can all hear me. First of all, many thanks for showing up for two reasons, because personally it's really nice to have such a large crowd, and also because it proves to me that we have really interest in testing. So having a packed room for a testing talk, I really like that. So let's start with the boring things. It's me. And do we have feedback in the audio? Do we have feedback in the audio? Okay. Well, the question is, I have some feedback, but that's okay. Okay, that's fine. So the boring thing, most boring, hopefully, about this talk would be me. The only relevant fact, apart from the things that I'm from Munich, is that I work as a freelancer, which means I see a lot of different projects with different project setups. Some are very mature testing processes and others less so. I also see projects often that have, let's say, a bit of pressure in terms of time, where testing is something that needs to be quick. And that's something to keep in mind in this talk. I really talk from some experience about things that could go wrong. In terms of expectation management for this talk, what I'd really like for this talk to achieve is just, if you go maybe outside in the hallway or if you're home, to try a couple of new things. Particular mutation testing, which is one of the large subjects of this talk, but potentially also property-based testing or something else. I usually do these talks because I'm interested in testing, and I try out, for me, new things. Mutation testing was something relatively new to me, and I'd like to share some basic experiences, but I don't want to take for your experience trying it yourself. With that said, the main structure of this talk is basically what makes a good test, what makes good test effectiveness, and second, how does mutation testing achieve that? So, what makes good tests? This is a part of the talk where most of you hopefully are bored. I'll take it actually as a compliment as you fall asleep, because that means that you already know what good testing is. Good tests, for me, comes down to the 5 E's. There are 3 easy E's, which is the pure existence of tests. Thank you so much. Which is the pure existence of tests. So the baseline is we do have some tests, hopefully automated. The next thing is these tests actually get executed and don't lie in a source repository somewhere because we have checked the checkbox with having tests. Hopefully in most of your projects it's not the case. And finally, it's slightly more sophisticated. We have enough tests by some metric. It can mean that we have a certain number of tests, or it can mean that we have certain coverage statistics. These are the easy goals, because they're easy to check, they're easy to communicate to management, and they're relatively easy to achieve. And sometimes I have situations where just these criteria are in a contract. So one supplier said, we will build your software system, and we promise we will have tests done. And that's obviously a problem. The important, basically the golden E's, the things we want to achieve, is efficiency and effectiveness. And, well, let's look into what can this mean. Efficiency, to nobody's surprise, mostly means automation, for the usual reasons. A test that is not automated takes too much time. You have to schedule testers, and as long as the project runs, it is always something that will fall by the wayside. Tests are always in competition with other things that are on the schedule, and unfortunately, they tend to lose. You have to automate your tests. Also, test execution has to be easy. If it takes too long, if it takes setup because the maintenance is too hard, or if the execution time is too long, then somebody will say the build process is taking too long, we have to cut the number of tests down. So we also need to have our tests small and efficient. And this means something else, and that's something that I had to learn over my, let's call it career, for lack of a better term. It means that we need to have few end-to-end tests. I'm a big fan of end-to-end tests because they're very close to the user workflow. If you talk with a domain expert and you can show them an automated test, it's something they understand, especially if you have UI automation. It's something where they have a feeling that this test achieves something. And also you cover all the corner cases. With an end-to-end test, you can cover connectivity issues, misconfiguration in infrastructure, all these things like that. But they are expensive, both in setting up and maintenance, because you have to touch more systems that might change, but also just in times of test execution. Can, of course, always get more resources. That means in your testing pyramid, the very top, basically the headstones, the thing you want to achieve are end-to-end tests, the nicest thing. But what you need is a foundation of integration tests that do slightly less, test service integration, test contracts, and a big firm foundation of unit tests. Unit tests are the tests where you can actually put in testing values, where you can test for all the different scenarios that you have in your project. And they're the ones that are, given some sort, can be a challenge, are also ones that are easiest to automate. Of course, if your system has too much state, has too much intermingled classes, setting tests may be hard, but if you can write it yourself or conceive your developers to write a system that is testable, this is the thing you want. You want many automated unit tests. Okay, efficiency. We have now many tests that we can run often, they execute quickly. We also want to write good tests. The good test ultimately is a test that helps to find bugs and locate bugs. Or slightly different things. The location part actually applies to isolation and single responsibility. Each test should fail or succeed on its own. So if you test something that is a long process and you have tests along the step, if the first test fails and also leads to the failure of all the other tests, that's not ideal because it makes it harder to interpret your test results. If you have a CI pipeline running and you notice that Friday afternoon when you're already slightly tired that many tests are failing, you don't want that. You want one specific test to fail so you know what's going wrong. Single responsibility is related. You also don't want to test all different functions in one test. Single small tests that you can change, like single functions in your code, and you have a good idea that things are going wrong and where they are going wrong. And even more important, meaningful assertions and expected values. The thing about test automation is not to have tests that run, but to have tests that can find bugs. In order to find bugs, we'll have to think about what our system is actually supposed to do and where it could go wrong. And this leads us over to coverage. Because coverage, in many projects, is one of the main statistics that people use to judge their test quality. If there are any particular discussions about how is our testing going, how is test automation going, you often talk about coverage statistics. That's why I want to spend a couple of slides about how does coverage relate to good tests. The good and the bad answer is it helps, it is necessary, but it is not sufficient. What does it mean? If you have zero coverage, you know that you have no tests for your code. That's a bad sign, that it means that you have to write more tests. If, however, you have 100% coverage, which mostly means either statement or branch coverage, we'll go into that, it does not mean that your code is actually tested. It just means that the test code touches the code. Let's go for an extremely stupid example. And no, it's almost laughable, but bear with me. So we have this micro function here, basically one conditional, a simple calculation, and a return. To test that, we would need to test two branches and essentially these 3 lines of code. So we can do this with these 2, let's call them tests. And if you write PyTest coverage, you will see that you have 100% branch and 100% statement coverage. Now, it's obvious you have no asserts. That wouldn't happen in production, hopefully. But it proves that you can have a test that does not really test the relevant outcome. Could it apply in reality? Yes and no. You could forget the assert. But more complex, you could be in a situation where you say, I want to achieve my coverage goals, And let's quickly think which values do I need to test. I take this one, and I have a test, and I'm mostly done. It could also mean that you test only, for example, that a function throws an exception or does not throw an exception. So the coverage code actually doesn't tell you much about any behavior, for what anything that your test is doing or not doing. Coverage can also lead to another problem, and that's related to Gotthart's law. Gotthart's law essentially says, if you have any measure and you make this measure a target, so people get judged by it, paid by it, get their bonus payments based on it, this measure will be corrupted and will cease to be a good measure. So take an example. If your management said, from tomorrow on, we will give bonus payments to the developers who write the most lines of code. Some of you would say, it's not something I do, I'm a good engineer, I'm not doing it. But after a couple of months, when you see that your colleagues take home more money, maybe you would say, okay, I'll just keep this function in, copy-paste it somewhere, and I get my money. If you do that with testers and say, I want test coverage as a goal, especially if you have a complex project and potentially, let's say, a certain power dynamic in the project, it can become really toxic really fast. Because you will have some people who only get home if they get the coverage value up. And believe me, they will get the coverage value up. They will not necessarily write good tests. They will do what we saw earlier, but they will cover the code with branch and statement coverage. And that's something really to avoid, and that's why I would really implore, treat coverage as a guideline, as a baseline, but not as a goal. Rather have lower coverage and good tests. If you say that's particularly code, we will go to it later, or it is not as function critical as other code, as to say we need blanket 80% coverage, 90% coverage, what have you. What helps to consider is also what we really want if we talk about good coverage. It's not necessarily line and branch coverage, what we saw before. What we ideally want is complex condition coverage or path coverage. So what it would mean is in path coverage that for every possible way through your program, so is manager, is senior, etc., you want to cover this path. Essentially, in every possible way that the execution flow can get through the conditions, you want to cover it. That's the ideal, because then you can really see, okay, what could happen to my project, to my program. The challenge, as so often, is that it is not really possible. So let's stay simple. If we wanted to go for complex path coverage, we can also see we have many more test values to consider. In just a simple example, with essentially 3 branches and some redundancy, than we would have for branch and statement coverage. Now, if you consider that you don't only have Boolean input values, but category input values or continuous input values, and potentially more states and 3 variables, you can easily imagine that you have essentially an explosion of possible input passes and you can't cover anything. Still, the idea to consider path coverage, or these more complex coverage, as a guideline to say what else can I consider in testing, beyond just having the different branches covered, beyond just having the statements covered. That's something where coverage as a metric can be helpful. Unfortunately, the tool support for path coverage, both in achieving it and measuring it, is not as good as for the other coverage types. But as a thinking tool, it's good. So, what have we seen? We know what good tests are. We want good tests, effective tests that finds bugs that we can execute quickly. We have seen that coverage can be a guidance, but as soon as it becomes the goal of the testing process, we run into problems. Now, what can we actually do better? We already said that. Path coverage is a thinking aid. What can I do? How can I go through my program? What could go wrong? Which state could follow which state in theory or in practice? Go into the debugger and play with variables and see what happens. Try different input tables and just play around with values. See what you can go through a project. How you can go to your project. Or we can test the test ourselves. Now, I have to apologize. I see that we have 10 minutes, so the next slides will be slightly quick. Remember the things that are set on the slides and investigate them partially yourself. I'll have to speed up a little bit. We can actually do 4 different kinds of things. We can get more and better input values. And we can do this either by hand or automated. Table-driven testing and behavior-driven testing are essentially ways to get domain expert, non-developers into your testing process, or get yourself into a thinking mode where you're not so much thinking about how the program works, but what is possibly in terms of input values, what can happen. Property-based testing is the same process, but letting the machine helping you. So briefly to cover that, table-driven testing is just, in essence, the easiest ways to parameterize your PyTest function and think these are the input values, these are the output values, and it makes it quite easy to come up with different combinations, different expectations. That's nice. What I've made quite good experience is having an Excel file, reading the Excel file with Python and using this for testing values, because it makes it easy to sit down with domain experts and an Excel file and say, what could the different scenarios be? Not with source code, they don't necessarily understand that. Behavior-driven testing is table-driven testing on steroids. Things get much more understanding. This is more or less documentation. It's not mostly for writing. It gets longer, but it's for reading. The disadvantage is you have to write extra code. But behavior-driven testing is a good communication documentation tool. Property-based testing essentially says the computer, I have a simple function or a complex function, and I want to basically have some assertions. So I know for the input of integers, the addition of a and b will be the same as the addition of b and a. The addition to any number and 0 will always be the number. And the property-based testing framework will then essentially search the parameter space and come down with combination where this hopefully it will find that everything works, but it may find combinations where these assertions don't apply. And mutation-based testing is a slightly outlier because it says us we want to change or we want to test our test code directly. How can we do that? We actually break our code. We are all good in introducing typos into our code, at least I am, but we can always use some help. And this help is mutation testing. It introduces small bugs, the idea being typos, off by 1 errors, wrong operands, equal less instead of equal, and then runs your tests. And if your tests still work with a mutated code, you should investigate why. To give an example, we could, this is all basically supported in all mutation test frameworks, but I use MutMut. You can have just having plus exchange to minus, multiplication by division, true to false. You can have string manipulations, etc. This is the easy overview. For more detail, this is a table of the operations supported by MutMut. Too much information. Just consider it a takeaway. There are many things that mutation testing may break about your code. How does it work in practice? We have gone our one extremely easy function. And for some reason, we decided that all our test cases only consider the option to test with 0. Now, if we ran a mutation test with that, we can only have one mutation. I'll spoil it a little bit. It will change this one here against minus. And for this particular test suite, we will see that the mutation will survive. This is this frowny here. The frowny says, I had made a mutation and your test suite didn't find it. Now, if we add an additional test case, where we actually add a value to the test case, then we will find the mutation. Now imagine this a few thousand times, and you have a mutation test, and you can see how many typos you find with your test base. And the way you would use this in practice is you have your code with your test suite, you run a mutation test. So the mutation test will run all your tests, again, all the found mutations, potentially, and will then say, okay, I have found so and so many mutations, you've covered so and so much % of them, but those are the ones that are survived. The tools usually give you a way to go through them, to investigate them, to write more tests, and then you can repeat. There are 2 tools. I won't go into details. The takeaway is start with mut-mut. If mut-mut is not enough for you, go with cosmic ray. They're both major tools. There are other tools. Maintenance is an issue. So that's an issue where many, let's say, academic frameworks were written with many interesting ideas, but, well, they use only outdated Python versions. What's the limitations? First of all, as you can imagine, typos are not necessarily the best sought-out changes to your code. So there are mutations that actually would survive because they don't change the program much. If we take x by x or minus, if we take x to a negative value and return x by x, it wouldn't change the outcome of the value. The other thing I already went into that is computational cost. If we have a simple implementation, it will run a long, long time. All these frameworks run parallel tests, but it can still take some time. And then are mutants that are actually not useful. You're changing tests in log messages. You could write a test to find out whether your log messages have spelling errors, but it's probably not the best use of your time. If all else is covered, you can do it. Performance considerations, in essence, don't consider it a normal testing step. Do it step by step or optimize. This is probably only something you will do if you have some experience with mutation testing. So first advice, run an experiment, see if you have any surprises in your code base. And that already brings us to the famous last words. The conclusion of this talk is have efficient, effective tests. Effectiveness relates to coverage. You want high coverage, but it is not enough. You have to also look into ways to get effective testing values. And potentially, you also want to test your tests to cover another corner case. And with this combination, you can increase the quality of your test suite. And the most important thing, the call to action, these are the things I would encourage you to do if you have the time, if you have a rainy afternoon. Try mutation testing. Pick a small code base to begin with. It can be a toy. Doesn't have to be something that is really from production because it will likely overwhelm you with findings. And just develop a feeling on what feedback do I get? Is it something that I can apply to my tests? If you have something that is conditions heavy, where you have many less than equals comparisons, many simple calculations, it might be a good spot. For database code, probably less so. Property-based testing. We only skipped it in a few seconds, but it's also quite interesting approach because it really means that you have to think what preconditions do I have to hold for my code every time? Is there something that I'm absolutely sure of? And can I generate different input values to test this? So these are the tools that I use, and both are extremely easy to use and set up. You can probably download them with the conference Wi-Fi and try them in the hallway. Write a testing table. That's the easy way to have if you have a complex function, just try to sit down, either alone with a colleague, and think about what are different values, preconditions or states of your programs can be values in this condition, and what should they trigger? What would be expected outcomes? And finally, check path coverage in your head, maybe with a piece of paper, just writing down the execution path, and think, did I really have tests for all this? Do I cover all this? Really in terms of values. Okay, 1 minute left. So I hope I didn't rush too much. Thank you in any case for attending. Again, try new stuff, and yeah, thanks for staying and listening.
Thank you, Stefan, for the wonderful talk. And now moving to the audience, do you have any questions for Stefan?
Hey, thank you for your nice talk. I was wondering, if I was able to start with Moot or a different, the Cosmic Ray package, can I just use the standard configuration, or do you have some recommendations on the configuration of these tools?
Start with there are two aspects to it. First, of the tool configuration, and there you can pretty much use a standard. What you probably want to do is to limit it. And you can limit it on both sides, on the code sides and on the test sides. So if you say, I only want to cover specific modules, you can do this. There are also code annotations where you can say, I don't want to have a mutation for this line. This can be useful because even with my toy example in the beginning, I found one particular bug for Mut, and this bug is related to the way it works. It does source code rewriting, so it does not use the AST, it uses the source code, makes a copy on disk and rewrites it, and sometimes it introduces syntax errors. And if it introduces syntax errors, it may hang. So this is something on the code side. And on the testing side, you can also say, I only want to consider these particular test cases. Welcome.
I think I understood that you established that requiring a certain code coverage on the source code doesn't really make sense. Would you say that requiring code coverage on the test, maybe like saying that all the tests have to pass, is something that you would recommend?
Yeah, if your tests are well maintained. So if I got the question correctly, coverage is important, but it is not that is not sufficient. You need coverage, but it shouldn't guide your testing process. Test execution and success, that's something you have to review. It's basically a bug triage. So if your tests fail, we have two decisions, one after another. First decision is this test giving me the intended result? So is this test correct, or is it the wrong test? It should be a good test, so let's go to the next step. Then the next question is this error expected or acceptable? So I wouldn't say all tests have to pass, because if you say that all tests pass, you incentivize commenting out non-working tests. And so it shouldn't be an automatic fail if the test fails. It should be an input for a technical debt review, for a stakeholder meeting, for whatever. So it should be something you keep track of, so it doesn't get forgotten, but not lead to an automated decision.
Hello, I have a question. What is your stance on TDD? Because some of the ideas you presented look like a great idea for TDD, like the testing table or the behavioral development.
Yeah, it's actually a hard question. I want to like it. I find myself to think differently. So if I sit down and want to write something, I find it's useful to come up with an interface and then write a toy implementation and then write the tests. I can see where it is coming from. I can see it in the context of pair programming, so basically behavior-driven programming for developers. But in most situations where I worked, it was not done. So maybe I just need more, let's say, training, more exposure to it, but my way of thinking is usually interface expectation and not really. And interface, basically interface, sample implementation, and then, okay, what are the different ways that code could break?
Okay, thank you.
Welcome.
One last question.
What would your strategy be for introducing mutation testing to a large project and a team? Should we be putting something into CI for PRs, or how would you go about it?
Start with a small part of the project. So what you could do is, just for information, see if you run it on your whole project, how long does it take? And how much do you find? If it does find, if it is acceptable, it takes an hour, 2 hours or so, and you have something where you say you have 100 survivors, okay, you will probably have more. And in this case, start with calculation-heavy code, with code well, where either you suspect already that you have bugs because you haven't spent so much time on testing or because it is highly complicated. Then you mutation testing, and then for the mutants that you find, think, okay, does it make sense? And then you'll probably have to invest some time to comment out mutants that don't make sense. That would be these unproductive mutants where it changes a log message or it changes a value that is never used again in the function. And this will probably give you a feeling, and do I get value out of that? I wouldn't consider it a necessary tool. It is just another source of information about your project testing health.
Thank you, everybody. We have run out of time, so we have to move to the next talk. Thank you, Stefan, for the presentation. Thank you, everybody.